The implications of secondary transfer of gunshot residue in forensic science. Understanding gunshot residue and the role of SEM EDX in forensic analysis. The definition of gunshot residue. What is gunshot residue? Gunshot residue consists of tiny particles produced when a firearm is discharged. These particles are composed of burnt and unburnt propellant particles, as well as elements from the bullet, cartridge case, and the firearm itself. The forensic importance. Forensic importance of GSR analysis is crucial in forensic science for determining whether someone has discharged a firearm or has been in the immediate vicinity of a firearm when it was discharged. It helps in reconstructing crime scenes involving firearms. Introduction to SEM EDX. So what is SEM EDX? So this stands for scanning electron microscopy with energy dispersive X-ray spectroscopy, SEM EDX for short. It is a combined technique that allows detailed visualization and chemical analysis of samples at microscopic levels. So the role in analyzing GSR, gunshot residue. So SEM EDX provides a powerful means of identifying gunshot residue particles based on their unique shape and elemental composition. It can detect specific elements such as lead, barium, antimony, which are indicative of gunshot residue. The advantages for forensic analysis. The technique's high resolution enables the detection of analysis of very small particles, which is crucial for accurate GSR analysis. This capability is essential for forensic investigations where detailed evidence collection is paramount. Relevance of SEM EDX in GSR analysis. So this comes from James French and his associates from 2013, where this image is displayed, and he shows that, or they show how when a gun is fired, you have gunshot residue will be in the vicinity, and it's acquired through firing the weapon, usually on the shooter's hands, the body, or if it's near another person or an object. The gunshot residue acquired through subsequent contact, such as the second object. So SEM EDX is integral to modern forensic practices for analyzing gunshot residue. It provides both qualitative and quantitative data that can be critical in linking suspects to criminal activities involving firearms. The method's precision enhances the reliability of forensic evidence presented in court, offering detailed insights that can support or refute claims regarding the use of firearms during criminal incidents. So this is a diagram of an SEM EDX instrument, as well as imaging showing gunshot residue from an SEM EDX instrument. So this works through backscattering of an electron detector, and then you've got a secondary electron detector, and you've got a super thin window for the EDX detector. So investigating secondary gunshot residue transfer using the SEM EDX. So the purpose of the study. The main objective of this study that James French and his associates did was to experimentally determine if and to what extent gunshot residue, or GSR, can undergo secondary transfer from a shooter to other individuals or to objects in realistic scenarios that closely mimic those encountered in real-world forensic cases. So research questions that were addressed. Okay. Can gunshot residue particles undergo secondary transfer to an individual who was not present at the time of firing? In what quantities does the transfer occur? Are particles of all sizes involved in the transfer? What are the practical implications for the collection, analysis, interpretation, and the presentation of gunshot residue evidence in forensic investigations? So the methodological approach for this is the study of utilizing scanning electron microscopy with energy dispersive X-ray spectroscopy, the SEM-EDX, to analyze the gunshot residue, the GSR samples were collected under controlled experimental conditions that were designed to simulate real-life interactions and scenarios involving firearms. So specific scenarios were tested, including direct firing, a handshake after firing, and the handling of a firearm after discharge to assess the potential for secondary transfer in each of the contexts. So the significance of forensic science in this aspect. Understanding the dynamics of secondary gunshot residue transfer is crucial for accurate crime scene reconstruction and can significantly impact the interpretation of forensic evidence, particularly in cases where the presence of GSR is a key factor in linking the suspect to a crime involving firearms. So the methodological approach to GSR transfer analysis. So the diagram listed is from Patel and Sharma, and it shows gunshot soot where the arrows are in A, well, and in B, on the left hand of a person that was taken at the crime scene. And the soot deposition likely occurred as the muzzle of the weapon, in this case it was a shotgun, passed by the left hand when it recoiled out of, in this case, out of the weapon when it hit into another object. In this case, it ended up being a person. So it shows the tip of the index finger that has a pattern of blood stain from back spatter, but it also shows the soot deposits that happen from the gunshot residue after the weapon was discharged. So there's your experimental methodology, choice of firearm and ammunition. For the study, this experiment was conducted using a Sig Sauer P226, which is different from other weapons in how they distribute their gunshot residue. This one is a commonly used 9mm self-loading pistol, ensuring the study's relevance to real-world forensic cases as being a common weapon that is used. So the firearm was loaded with a 9mm Luger 95-grain jacketed soft point 9P1 ammunition provided by Federal Ammunition, chosen for its typical use in law enforcement and civilian defense. So that way they could apply it more accurately to a real-world scenario. So the sampling technique: to capture GSR, 1/2 inch of aluminum SEM stubs covered with self-adhesive carbon discs were used. This, excuse me, this technique is widely recognized for its effectiveness in collecting a broad range of particle sizes. So sampling involved dabbing the SEM stubs onto the entire surface of the subject's hands 50 times to ensure a comprehensive capture of gunshot residue. So special attention was given to the webbed areas between the thumb and the forefinger, which is a common deposition site for gunshot residue, as the person is holding the gun and it hits right there in that webbed area. So experimental scenarios. So the first scenario was straight firing. The shooter fired 5 rounds to measure gunshot residue transfer directly from firearm discharge. Okay. Scenario 2, firing followed by a handshake. So after firing, the weapon was fired. Post-firing, the shooter engaged in a handshake with a second participant or a second person to assess gunshot residue transfer through personal contact from the shooter to maybe another person, innocent bystander, the victim, or another shooter. So scenario 3, firing followed by firearm exchange. So after discharging the firearm, the shooter handed the gun to another participant who briefly held it to evaluate gunshot residue transfer via object handling. So even though the secondary person did not fire the gun, was there gunshot residue on that person? So control and sample integrity. To minimize contamination, the experiments were carried out at a distance of 15 meters from the firing port. Each participant involved in the experiments washed their hands thoroughly before the test to serve as a control, ensuring that any GSR residue detected post-experiment was exclusively from the test firing and that there was no carryover. Quantitative findings on gunshot residue transfer across scenarios. So here are the overview of the findings. In scenario 1, the direct firing, there were high particle counts that were consistently observed, demonstrating substantial primary GSR deposition on the shooter, which is to be expected. Particle counts varied with each firing, reflecting changes in firearm cleanliness and operational conditions. Okay. Scenario 2, handshake transfer. Significant secondary transfer of gunshot residue was noted during handshakes post-firing. Particle counts varied across the runs, with some showing relatively high amounts of transfer, indicating that gunshot residue can readily move from one individual to another through direct contact. While the amount that's transferred varies, it is possible. So while maybe a little bit transfers or none transfers, it is possible for a lot to transfer. And this could show that someone had gunshot residue on their hand. Maybe they did fire it, maybe they didn't. Okay, scenario 3, firearm handling. Lower but notable gunshot residue transfer was recorded when a second participant handled the firearm post-discharge. So this suggests that a secondary transfer through an object, through that contact, but at a reduced level compared to direct human contact. So gunshot residue is possible through objects if the object already has the gunshot residue on it. So after the weapon is fired, you're going to have gunshot residue on the person who fired it and on the weapon. And that gunshot residue can transfer to another person from the object or from the person's hand. And this was indicative across the results as shown from French and others on their study when they did the 3 different scenarios. Obviously, the highest gunshot residue present is going to be on the person and the weapon from which it was directly fired. Okay. So, graphical representation. So, the bar graph shown on the left, figure 2, displays a bar graph comparing the gunshot residue particle counts across 3 scenarios for each experimental run. This visual will clearly show the variance in particle counts between the direct contact, scenario 1, the handshake, scenario 2, and the firearm handling in scenario 3. The data points include specific particle counts for each run within the scenarios. So in scenario 1, runs 1 had 206 particles. Run 2 had 335 particles, and Run 3 had 443 particles. So they were consistent across the board. They, in this case, got higher as they went. Scenario 2. Your runs 1 was 88, run 2 was 30, and run 3 was 129 particles. A lot of variance there, which suggests numerous different factors that are in play here. And the same can be said for scenario 3 as well, because it's still a secondary transfer, with runs 1 having 86 particles, run 2 having 18 particles, and run 3 having 14 particles. So it shows not as much transfer as in scenarios 1 and 2, especially not as much as in scenario 2. However, it is showing that there is still some transfer. Okay, the analysis of the results. So the implications of these results in a forensic context. This kind of highlights how secondary transfer varies significantly based on the nature of the contact and the time elapsed post-discharge. The importance of considering these variations when interpreting GSR evidence plays a role in criminal investigations, because it could potentially link someone as having used or fired a weapon who did not, in fact, fire a weapon, but came in contact with the person who did fire the weapon. And next is the gunshot residue particle size distribution across the scenarios. Okay. So this gives an overview of the particle size distribution. So it gives the range of the particle sizes detected in the study, emphasizes that GSR particles were categorized into several class sizes from submicron to over 100 microns. So each particle size is a critical factor in the forensic analysis, as it affects the probability of transfer and the interpretability of gunshot residue evidence. So scenario-specific findings. In scenario 1 with the direct firing, there were predominantly smaller particles that were found, with a modal class being 1 to 2.99 micrometers. This scenario also recorded the largest particles among the 3 scenarios, emphasizing this is the primary deposition directly from firing, which makes sense. That's where all that gunshot residue is coming from. Okay, in scenario 2, you've got the handshake transfer, a diverse range of particle size, including notably large particles, with one instance of a particle measuring 102.46 micrometers transferred during a handshake. So this highlights that significant and sizable gunshot residue particles can be transferred through direct human contact. And then lastly, we've got scenario 3, which is firearm handling. Generally featured smaller particles compared to the handshake scenario. You've got the absence of very large particles in this scenario, suggesting that the object mediated transfers from one object to the other, and that might be more selective or less efficient in transferring larger particles. Okay, so this graphical representation is from French et al. From 2013, and this is the particle size distribution. The chart displays each scenario showing the frequency of each particle size class. Visually represents how the particle size varies across the different modes of transportation. It also includes the total number of particles and the average across each scenario, across the runs, and the largest particle as well. So the implications of the forensic analysis. Okay, so the occurrence of the very large particle, a little over 102, transferred in scenario 2, it's a critical point for forensic considerations for sure. The presence of larger particles in secondary transfer scenarios can complicate forensic interpretations, because your larger particles are typically expected only in primary gunshot residue deposits. So that challenges assumptions about proximity to a discharged firearm. So it's important to understand the distribution of particle sizes that helps reconstruct a sequence of events and potentially identifying or excluding suspects based on the gunshot residue. Okay, impact of secondary gunshot residue transfer on forensic protocols. So understanding the secondary transfer. So I'm going to begin by emphasizing the proven ability of gunshot residue to undergo secondary transfer in significant quantities and across different scenarios as demonstrated by the study French et al. 2013. He highlights that gunshot residue can be transferred not only through direct contact with the shooter, but also via objects like the firearms, which does complicate the interpretation of forensic analysis. Not the analysis, but the evidence, interpreting the evidence. So the implications of the forensic protocols. You've got your revised sampling techniques. Okay, so this stresses the need for comprehensive gunshot residue sampling protocols that include not only primary suspects, but also other individuals and objects potentially involved in the incident. This approach is necessary to capture the full extent of GSR dispersion and transfer. So the analysis procedures. Okay, the forensic analysts must consider the possibility of secondary transfer when interpreting gunshot residue findings. This includes assessing the size and the quantity of the particles to differentiate between primary and secondary deposition. So case reconstruction and legal considerations. Okay, impact on judicial outcomes. Okay, so it's important to understand how secondary transfer can affect legal outcomes, particularly in cases where the presence of GSR is used to establish proximity to a shooting. So training and awareness. It's suggested that ongoing training for forensic professionals should include updates on the latest research regarding GSR dynamics, ensuring that analyses reflect the current understandings and prevent misinterpretations when dealing with gunshot residue. So recommendations for best practices, documentation and reporting. First off, okay, recommend that the forensic report should clearly document the potential for secondary transfer and its implications for each case. This transparency helps legal professionals better understand the nuances of evidence presented. Okay, second, your interdisciplinary collaboration. I would encourage, collaboration between forensic scientists, law enforcement, legal professionals. This way, we can establish protocols that consider all possible GSR transfer scenarios, enhancing the accuracy of credibility in forensic analysis. So there are several different stakeholders involved. You've got your police, your forensic scientists, your lawyers, all involved in handling GSR evidence. So this shows the need for the collaborative approach. Now, the diagram listed from Shrivastava and their associates in 2021 shows how gunshot residue is extracted. There's many different methods to extract gunshot residue and analyze gunshot residue. SEM EDX is mostly for the inorganic constituents of gunshot residue. So advancing gunshot residue analysis through further research. First up is future research and recommendations. Okay, there is a need for broader validation. You have different firearms and ammunition, and this emphasizes the importance of conducting similar studies using a variety of firearms and ammunition types. This will help generalize the findings and ensure that forensic protocols are robust and applicable under diverse conditions. Okay, cross-scenario validation. Recommended studies that replicate secondary transfer scenarios under different environmental and situational contexts to understand how factors like humidity, temperature, surface materials will affect gunshot residue transfer. One thing shown on the slide is from Krishna and Ahua from 2021, and they did a full paper on the different types of gunshot residue from different weapons, the bullet size, and the distance. And so figure 7 shows that the pattern distribution for gunshot residue attained by firing a 38-inch and a 9x19 millimeter ammunition at different shooting distances, and how that affects the gunshot residue transfer. Next is assessing gunshot residue decay rates. Okay, you've got persistent studies that highlight the need for systematic studies that examine how long gunshot residue remains detectable on various surfaces, including skin, clothing, any type of different materials that are found at crime scenes, because a person could fire a gun and then after so long that gunshot residue is no longer there, which doesn't mean that the gun wasn't fired. It just means that it may not have been fired recently. You've got impact of environmental factors. These factors suggest that researching how an environmental conditions influence the decay or persistence of gunshot residue, which could critically affect the interpretation of time since discharge in forensic investigations. Okay, next is the technological enhancements in gunshot residue analysis. Improvement of detection is first and foremost, the techniques behind that. So we've got to advocate for the development of more sensitive and faster detection methods for gunshot residue. This is to help improve efficiency and accuracy of forensic analysis. Also, think about automation and AI, artificial intelligence. Okay, this is a discussion that brings up the potential for incorporating automated systems and artificial intelligence in GSR analysis to standardize interpretations and reduce human error. And lastly, implications for forensic training and practice. Updated training modules. Recommend the integration of findings from ongoing and future research into training programs for forensic analysts to keep them abreast of the latest developments in gunshot residue science. And then guideline development. Okay, this suggests the creation of updated forensic guidelines that incorporate comprehensive strategies for gunshot residue collection, analysis, and interpretation, considering new research insights. So, the summary of the key findings, this is concluding insights and implications for forensic science. Okay, these findings challenge some traditional assumptions in forensic science, particularly regarding the direct involvement of individuals with firearms based solely on GSR presence. So I have to emphasize that the study conclusively demonstrated the potential for secondary transfer of GSR, showing significant transfer through direct human contact and interaction with objects, specifically firearms. Okay, it does highlight the variability in the quantity of gunshot residue and size of the particles transferred across different scenarios, including the presence of unexpectedly large particles during personal interactions such as handshakes. There's also implications for forensic analysis. The broader implications for crime scene processing. A more nuanced understanding of GSR can lead to a more accurate crime scene reconstruction and fair judicial processes. So there's a stress for the need for forensic analysts to consider the possibility of secondary GSR transfer in their evaluations. This is vital for ensuring the accuracy of the assessments and the fairness of judicial outcomes. Okay. Got to discuss how these findings necessitate comprehensive sampling strategies. That includes potential secondary transfer services and detailed documentation of all the individual interactions at or near the crime scene. Okay. The importance of ongoing research and adaptation. You've got enhancing crime scene investigations. In forensic methodologies, we must keep pace with new scientific findings. This ensures that forensic science continues to serve as a robust pillar of the criminal justice system. Okay. We outline how acknowledging the dynamics of secondary gunshot residue transfer can refine the approach to crime scene investigations, leading to a more accurate reconstruction and interpretation of those criminal events. These suggestions also give insights that should be integrated into standard forensic procedures, training programs to improve the handling, analysis, and interpretation of GSR evidence, and the impact on court evidence presentation. So this explains how the detailed understanding of GSR transfer mechanisms can assist forensic experts in presenting clear and more precise evidence in courts, helping to prevent misjudgments based on this misinterpretation of the gunshot residue evidence. Okay, we've got to have advocates for the inclusion of findings from studies like this in expert testimonies. This will enhance the transparency and educational value of the forensic evidence for the juries and the judges, because these people are not as educational and as adept in this knowledge as the experts are. So there has to be some interpretation there, some education there to explain all of this. These are the references that were used in creating this PowerPoint and in the graphical representations, charts, graphs, pictures that were included in the PowerPoint. Thank you.